Yes. So there are two terms, logistic plus regression. So we are having is a sort of classification algorithm where we are having output in the form of class. For example, we are having 0, 1, pass, fail, etc. So if you have a requirement like this, we'll go for logistic regression. If you see, let me show you one case there. So if a response variable is not a continuous value, in the case of a linear regression, we do have a limitation that our linear regression output should be a continuous value. It should not be a class format. But in the case of logistic, we are looking for output in the form of happy or sad sort of scenario. Means either we are getting a class format output, which is not possible in the case of our linear regression. So linear regression would not be a right choice for putting classification algorithm in place. When the binary response is viable, binary, when you say binary is true or false, or we can have a multi class algorithm also, which can be solved using logistic regressions. So currently we are working on the class case 0 or 1. I'm taking example for 0, 1 only. Then we'll go for multi variable logistic regression. So first in logistic, we are saying classification algorithm. Regression, as we had discussed already, is a sort of equation which is a straight line sort of case. And we were having equation like this: a y equal to ax plus b, where a is a slope, b is my intercept. So indirectly we are saying we are using this linear regression for putting my classification algorithm in place. So that's why we are calling it logistic regression. So in standard terms, when we say when we are having linear regression, we are having data like this. We are getting line like this. So let me take something else. So we are looking for line as a normal case, but in the case of logistic, we are never get this straight line as an output. In logistic, we are generally getting output in the terms of flat S curve sort of thing. So are getting anything like this option in sort of logistic regression, or you might get this case also. So in that case, we are making two thresholds. First threshold is my 0, other threshold is my 1. In my if I take example of 0, 1, in my case I am expecting what I am saying in my intersection point approximate would be my 0.5. Anything with 0.5 or above is treated as a 1. Anything below 0.5 is treated as 0. That's the threshold which I am looking for classification. So in general terms, we are saying we first get the probability of y. What is the probability of getting y? My equation would be like 1 by 1 plus the exponential of your linear regression, or you can say your slope and intercept which you get from the logistic regression line. So that is, you can say ax plus b. So that is my calculation, which where I am getting this output between 0 to 1. So you can say it's a sigmoid sort of function. It's give me a value between 0 to 1. So if my threshold value, the probability of y, which I am getting, is greater than or equal to 0.5, I'll name it output as a 1. If it is less than 0.5, I'll accept this as a 0. So I am saying mine threshold are 0 and 1. So based on probability or percentage, I'll decide whether I am getting 0 or 1 as an output. So in our case, we are in two options with this.